How much are human activities heating Earth? Greenhouse gases are referred to as forcing agents because of their ability to change the planet's energy balance. A forcing agent can push Earth's temperature up or down. Greenhouse gases differ in their forcing power. For example, a single methane molecule has about 25 times the warming power of a single CO2 molecule. However, methane has a shorter lifetime in the atmosphere and is less abundant, while CO2 has a larger warming effect because it is much more abundant and stays in the atmosphere for much longer periods of time. Scientists can calculate the forcing power of greenhouse gases based on the changes in their concentrations over time, and on physically based calculations of how they transfer energy through the atmosphere. Some forcing agents push Earth's energy balance toward cooling, offsetting some of the heating associated with greenhouse gases. For example, some aerosols, which are tiny liquid or solid particles, such as sea spray or visible air pollution suspended in the atmosphere, have a cooling effect because they scatter a portion of incoming sunlight back into space. Human activities, especially the burning of fossil fuels, have increased the number of aerosol particles in the atmosphere, particularly over and around major urban and industrial areas. Changes in land use and land cover are another way that human activities are influencing Earth's climate. And deforestation is responsible for 10 to 20% of the excess CO2 emitted to the atmosphere. As mentioned previously, agriculture contributes nitrous oxide and methane. Changes in land use and land cover also modify the reflectivity of Earth's surface. The more reflective a surface, the more sunlight is sent back to space. Cropland is generally more reflective than undisturbed forest, while urban areas often reflect less energy than undisturbed land. Globally, human land use changes have had a slight cooling effect. When all human and natural forcing agents are considered together, scientists have calculated that the net change in climate forcing between 1750 and 2005 is pushing Earth toward warming. The extra energy is about 1.6 watts per square meter on the surface of Earth. When multiplied by the total surface area of Earth, this represents more than 800 trillion watts of energy. This energy is being added to Earth's climate system every second of every day. That means each year we add to the climate system more than 50 times the amount of power produced annually by all the power plants of the world combined. The total amount of warming that will occur in response to a climate forcing is determined by a variety of feedbacks, which either amplify or dampen the initial change. For example, as Earth warms, polar snow and ice melt away, allowing the darker colored land and oceans to absorb more heat, causing Earth to become even warmer, which leads to more snow and ice melt, and so on. Another important feedback involves water vapor. The amount of water vapor in the atmosphere increases as the ocean surface and the lower atmosphere warm up. Warming of 1 degree Celsius, or 1.8 degrees Fahrenheit, increases water vapor by about 7%. Because water vapor is also a greenhouse gas, this increase causes additional warming. Feedbacks that reinforce the initial climate forcing are referred to in the scientific community as positive or amplifying feedbacks. There is an inherent lag time in the warming caused by a given forcing. This lag occurs because it takes time for parts of the Earth's climate system, especially the massive oceans, to warm or cool. Even if by magic we could hold all human-produced forcing agents at present-day values, Earth would continue to warm well beyond the 1.4 degrees Fahrenheit already observed because of human emissions to date.